Viewers, this video lecture is for the topic regular expressions and finite automata for the subject theory of computation from second unit. And the objectives are to understand the concepts of regular expressions, to analyze the problems for converting regular expression into finite automata systems and vice versa. So in this topic, regular expression and finite automata, we will study about some problems and theorems that will help us to construct the finite automata for the given regular expression and to derive the regular expression for the given finite automata systems. So we are having some methods. First of all, we can construct the finite automata system for the given regular expression with the help of Thomson's construction method, and we can identify the regular when we given with the finite automata system, we can derive or we can identify the regular expression for the given system with the three methods. There are three methods are there to derive the regular expression. They are Ordnance theorem, regular expression equation method, and state elimination method. First of all, we are going to see Thomson's construction method. So the Thomson's construction method is to derive the regular expression, to construct the finite automata system, especially NFA, non-deterministic finite automata systems with epsilon transitions for the given regular expression. So in these problems, we will be given with the regular expression. We have to construct the NFA systems for the corresponding regular expression. First of all, we are going to see some basic structures for some simple regular expressions. Then only we can do the problems. First of all, if the regular expression equal to epsilon, simply epsilon. So in this case, we should understand the system is reaching the final state without consuming any valid input symbol. That case will be called as epsilon. So there will be only there will be two states, that is starting state, final state. System will reach the final state from the starting state by consuming epsilon. That means system reach the final state from the starting state without consuming any symbol. So that will be labeled as epsilon. So this is the diagram for regular expression epsilon. And the second one is, if the regular expression equal to simply A. A means we should understand there is only one input symbol A. So the system will reach the final state by consuming A. Since there will be in the string consist of only one symbol, we should understand there will be two states, starting state and final state. So the diagram will be like this. And the third case is for the regular expression A plus B. A plus B means we should understand it is the union operation. A or B. Our input string have A or B. Either there are two possibilities. System will reach the final state by consuming either A or B. So in the diagram we have to draw two alternate paths. Since this in this method we have to construct the non-deterministic finite automata with epsilon transitions, and for the regular expressions having plus operation, that is union operation, we have to include the epsilon edges in between the other symbol, valid symbol edges. So in this diagram we have to put the edges for the symbol A in one direction, one path, and B in another path, but in between the A and states we have in alternate edges we have to put epsilon symbol. So this is the basic structure, this is the fixed structure for A plus B. So in this diagram we can understand there are two paths, that is Q0, epsilon, A. The circles are empty, since for the problems, while doing the problems, after constructing the entire structure we have to put the state names starting from Q0. Okay, in the step while doing the problems we will construct the entire diagram in a step-by-step manner. So finally, at last only we can put the name for the states. So this is the structure for A plus B. Now we are going to see the structure for AB. AB means A dot B. This is the concatenation operation in between A and B. That is A, B. Two symbols are must. Two symbols will be applied consecutively to reach the final state. That is, initially A will be applied and from that state B will be applied to reach the final state. So this will be the structure, but in the previous case A plus B means that is alternate path, alternate option, either A or B. A, B means concatenation means there should be two symbols. Both A and B should be applied in a sequence manner to reach the final state. So this will be the structure. Then A star. Star means lean star. Star means we should remember one symbol will be repeatedly coming. In that case, we will put the operator A star. So while drawing the structure for A star, we have to draw the loop structure. Here also we have to put the intermediate edges with the epsilon symbol, and we have to draw the necessary loops. So this is the fixed structure for A star. That is, in the middle portion we have to draw two states, and in between that we have to apply A, and we have to draw the loop from the second state to the first state with the label A. And again it will be previously we have to extend the states with the epsilon symbols. So this is the basic structure for fixed structure for A star. Now we are going to see the problem. Construct the epsilon NFA for the given regular expression using Thompson's construction. So we will be given with the regular expression A plus B star A dot B. Now we will do the problem in a step-by-step manner. Initially we are going to draw the basic structure for A, R equal to A. So this is the structure. Now we are going to, if R equal to B, this will be the structure. Now we are in step 3, we are going to construct the structure for R equal to A plus B. So already in the basic definition we have seen the structure for A plus B. For A plus B, we have to draw the basic structure. We have to draw two alternate paths from starting state to final state. We have to draw two alternate paths from starting state to final state. One path will consuming the input symbol A, other path will consuming the input symbol B. And in the step 4, we are going to draw the structure for A plus B the whole power star. A plus B the whole power star is, that means A plus B will be applied repeatedly for number of times. So again we have to construct the loop. So previously we have drawn for A plus B. Then we have to drag some loop from from different states, as like in this diagram. Now we are going to extend the diagram for the remaining symbol AB. So from the step 4 we have to add two more states to reach the final state. For one state we have to apply A, and the second state we have to apply B, and finally we can reach the final state. So in this problem we have to do the operation by step manner only. So this is the whole diagram for our regular expression A plus B the whole power star dot A dot B. After putting all the necessary states only, we can put the name of the state. We have to put number to the states like Q0, Q1, Q2, Q3, etc. So in our problem, as per our regular expression, the final state is Q9. When we notify the final state, it should be drawn with double-lined circle. Similarly, we are going to have the problem to construct the diagram, construct the finite automata system for a dot a plus b the whole power star dot a b b. So here also the main thing is a plus b the whole power star. So in the step 2 we are seeing the diagram for a plus b, and a plus b star means this is the structure, that is we are having some loops, forward and backward loops. This is the structure for a plus b star. Then previously we have to add one symbol a. For that we have to add some one state previously. Then after that we have to add states and labels for bb, two simples, two consecutive b's. So this is the final structure. Now we are going to see Ordnance theorem. So Ordnance theorem is used to derive the regular expression for the given finite automata. So first of all, there will be the theorem. By following the theorem, by applying the equations in the theorem, we will do the problems. So in the theorem we are considering, let p and q be two regular expressions over the alphabet sigma. If p does not contain null string epsilon, then r equal to q plus rp has the unique solution r equal to qp star. This is the important equations. So we will use this particular equation in all problems, like that is q plus rp equal to qp star. Q plus rp equal to qp star. Q or p's are regular expressions. Now we are going to see the proof for the equation r equal to q plus rp. Q plus rp equal to q plus, we are substituting qp star in the place of r dot p. Now we are taking q as the common term, then inside the bracket we will get epsilon. That is, when we take q from q, the remaining thing will be epsilon. This will be applicable in this kind of problems. So when we take q from q, remaining thing will be epsilon plus p star dot p. From the second term we are taking q outside, so p star dot p. And in the next step, p star p can be written as p star. P star means many number of p's, isn't it? So p star p can be written as p star. And in the next step, epsilon will get eliminated. Epsilon is nothing. Epsilon is null string, null, simple. So finally we are getting qp star. So thus we are proving q plus rp equal to qp star. This is the basic formula that we will use in the problems. Then there are set of principles are there for the Ordnance theorem, like we are having in the problem the input will be, that is we will be given with some finite automata system diagrammatic representation from the system, from the structure of the system. We have to identify the regular expression. So we are deriving like this. The system may consist of the set of states q1 to qn, and here we are going to derive something, that is alpha ij will be the set of labels of edges from qi to qj. Qi is one state, qj is another one state. Two states may have the edges. So alpha ij is the set of labels of edges from qi to qj. Then according to that we will write equations for the different states available in our system. For example, commonly we are deriving q1, q2 up to qn. For q1, for example, we can derive the equation q1 dot alpha 11 plus q2 dot alpha 21 plus etc. up to qn dot alpha n1. For the first state, for the starting state, we have to add epsilon in the equation at last. Similarly, for other states, we have to derive the equation. And we will perform the substitutions, and finally we will get the regular expression. Now we can see the problem. So this is the problem. This is the finite automata system given as the diagrammatic representation. We have to we have to derive the RE for that. So in the system we can identify there are three states, Q1, Q2, Q3. Q1 is the starting state. Also it is the final state. Other states are Q2, Q3. Now, and we have to check whether FA does not have epsilon moves. So this Ordnance theorem is applicable only to DFA, deterministic finite automata. And the step 2 only, we are going to apply the equations that we have derived in the theorem. The equation, and we are write the equations for all the states. We are having 3 states. So we will derive the equations for Q1, Q2, Q3. In the right hand side, what we have to write is Q1 is equal to, we have to look at the state Q1 initially. We have to identify what are all the incoming edges reaches to Q1. So we can see there are 2 incoming edges are coming to Q1. That is one edge with the label 0. One edge is same from Q1. Another one edge is coming from Q3. The label is label of the edge is 0. So that only we are going to write in the right hand side of the equation. That is Q1 is equal to Q1 dot 0. That is inward incoming edges coming to Q1 is, one is the same self loop, that is Q1 dot 0. Another one is Q3 dot 0. Q3 dot 0 means from the state Q3 and the symbol is 0. When we apply, that means when we apply 0 to Q3, the system is changing to Q1, isn't it? When we apply 0 to Q1, the system remains changes to Q1. That we are writing in this equations. Q1 equal to Q1 dot 0 plus Q3 dot 0. In the first state, we have to write plus epsilon. And for the Q2, we can identify Q2. We can tell what are all the incoming edges coming to Q2. One edge is coming from Q1 and the symbol is 1. Another one edge is coming from Q3 and the symbol is 1. Another one edge is self loop, that is the same state and the symbol is 1. So that we have written like Q2 equal to Q1 dot 1 plus Q2 dot 1 plus Q3 dot 1. And for the Q3, only one incoming edge is there, that is from Q2. So we have to write Q2 dot 0. So for Q3, we have written Q3 equal to Q2 dot 0. So that's, by that we got 3 equations. Now we are going to solve all these equations, and finally we have to resolve Q1. We have to do necessary substitutions on the right hand side of Q1. Q1 is nothing but the final state. For all the problems, we have to write the equations like this, and after that we have to make the substitutions on the right hand side of the final state. And finally, from the right hand side of the, after performing all the simplification, from the right hand side of the final state, we will get the regular expression for the given problem. That's all. So we are doing necessary substitutions, that is we are substituting 3 in 2, that is 3 having the value for Q3. We will apply the value of Q3 in equation number 2. We will get some string, something in the right hand side, and whenever we get some expression, we will try to consider the expression in Q plus RP manner. So Q plus RP then can be written in the model of QP star. Then again we are doing some substitutions. We are substituting equation number 4 in 1. We are simplifying it. If possible, we will take the common terms. Like here we are taken the Q1 as the common term, and then we will consider the expression as Q plus RP manner. So here in the simplification we can see RP plus Q. We are considering this Q plus RP or RP plus Q. So Q plus RP can be written as QP star. So in this equation, Q is epsilon. So Q epsilon P star. P means Q, 0 plus 1 dot 1 plus 0. So that is P. So P star means we have to put the whole power start, Q P star. So finally that is the regular expression. That is the simplified form of the right hand side of the final state, accepting state. In this problem, Q1 is the final state. So after performing the simplification, right hand side of the Q1, from the right hand side of the Q1, we will get the regular expression for the given problem. So in this way we have to do the problems in Ordnance theorem. Now we are going to see the possible questions. construct the finite automata system for the given regular expression, then state Ordnance theorem with example, then derive the regular expression for the given automata system using Ordnance theorem. Thank you all.